everyone, welcome to today's chemistry class. Today we'll be talking about introduction to chemistry. Please do endeavor to like this video, subscribe to my channel, click on the notification button so that whenever I post a new video you can always get notification. Is to expound daily and general application of chemistry. Enumerate career prospects in chemistry. Outline steps in scientific method. Outline and explain adverse effects in chemistry. Outline application of chemistry. So, look at chemistry as a science subject. Basically, chemistry is a science subject, and we say this because chemistry follows a systematic approach. Just like science, science is an organized body of knowledge gathered through a systematic experimentation and philosophical observations. Now, what do we mean by systematic? It simply means a kind of step-by-step order of doing things. Science is not about you just acquiring knowledge, but you must be able to use that knowledge to solve problems. However, when you are solving those problems, you don't just do things anyhow. You have to follow a step. You have to follow steps, rather. You have to follow steps to get your results. So it's just as if you want to carry out an experiment. There is always a method to follow. If they want to carry out surgery in hospital, they will always follow a procedure. They don't just wake up in the morning and just get to the theater and take their instrument and start to dissect or work on somebody. It doesn't go that way. They will always follow a procedure. So this procedure are systematic, and that's why we call it science. So chemistry is a science subject. Now we cannot say that chemistry it has to do with a systematic approach in observing, experimenting, getting results, and drawing out conclusions. So it's a major aspect of life because the food we eat, the clothes we wear, the house we live, the vehicle we use, in fact, knowledge of chemistry is applicable in all of this. Now let's look at the depth of chemistry. What is chemistry? Chemistry can be defined as a branch of science which deals with the study of the nature, structure, composition, properties, and uses of all forms of matter, and the changes in the structure and composition which matter undergoes. Okay, this definition might be lengthy, but we can just say that chemistry has to do with the study of the structure, composition, properties, uses, and the changes matters undergo. Now please know that the word matter is very important in this context. Now we know that matter is anything that has mass and occupies space. For instance, you and I were matter. The food you eat is a matter. The house you live on, the book you used to write, your pen, your phone, your shoe, name it, they are all matters. So when we are talking about that chemistry has to do with the composition, the structure, the properties, and the changes these matters undergo, we are looking at understanding matter itself. For instance, ice can change to liquid, that is from solid state to liquid state. What causes that? A chemist will want to understand what brings about that changes. So that's why the understanding of matter is very, very crucial, even in our daily lives. The understanding of matter is crucial. For instance, you make a gate, or if your parents they make a gate for their various building, and they have to paint that gate. Have you ever asked yourself why they are painting the gates? Now, the explanation behind this is just because the gate is made up of iron. Iron is a matter. Now, if the gate is not painted, that will expose the iron to oxygen in atmosphere or even water. So when water comes in contact with the iron can easily rust. So painting the gates will reduce the amount of water that gets to the iron, prolonging the lifespan of the gate. Okay, so for instance, so we can also see application or the use of understanding matter even in sun drying clothes. If you sun dry your clothes for too much, then you will know that the clothes will get faded as time goes on. So these are some of real life reasons why we really need to understand matter. And also, if we consider the case of let's say melting of candle, candle wax changing from the solid state to a kind of liquid molten state. Okay, talking about burning of wood changing from the firewood or maybe the wood itself to a kind of ash. These are changes, and it's from one state of matter to another. So it's very important for us to understand this change of state of matter, the way the matter changes, for you to really be able to know how to work with these matters. Okay, now we have branches of chemistry. Basically, we have three main branches, which are physical chemistry. And physical chemistry deals with the physical aspect of chemistry like quantum theory, electricity, and heat. Then we also have the organic chemistry that deals with the study of carbon and its compound. We have inorganic chemistry that deals with the study of elements, their properties, and use. So let's look at this activity quickly. Think about your daily activities such as cooking or cleaning. How do you think chemistry is involved in these activities? Can you provide examples where chemistry plays a role in your everyday life? Chemistry is the study of matter and its changes. Why do you think understanding matter is important for scientists? How does knowing about matter help us solve problems in the real world? Okay, you can pause the video to do the activity, then continue thereafter. Let's talk about scientific method of discovery. So sometimes people wonder that how the scientists get to know this. How did they know that when you put this and this together, it forms this? It's all about the way scientists carry out research. And that way is what we call the scientific method. By definition, we say scientific method can be defined as steps of acquiring knowledge that has characterized the development of science. They include question/observation. Now, you see, when we are talking about questions/observation, whenever there is a problem, scientists will always ask questions. They will observe, they will ask questions, before they now think of what to do. For instance, let's say there's a problem, and this problem has to do with growth of plants. A scientist can just ask a question that, what makes this plant to grow? They can also be observing the plant if it's growing or not. Then be thinking in their mind that what's really making this plant to grow. Now, after they are asking their question, putting some questions down, observing, then they come up with kind of hypothesis. Hypothesis is like an idea, So, and it's not always true. Sometimes the idea could come out true, while sometimes the idea may not come out true. For instance, the problem is, okay, what makes this plant to grow? They cannot think that, could it be the sunlight? Could it be water? Could it be absence of sunlight? These are hypotheses. All this they are putting down is hypothesis, like an idea of what could cause the plant to grow. So after the questioning and the observation, scientists will draw out what we call hypothesis. Then after the hypothesis, they go into experiments. So they cannot have maybe several plants. They can subject some plant to light and water. They might subject another plant to maybe absence of light. They might subject another plant to maybe only light but no water. Then they might subject another plant to presence of light, presence of water, presence of CO2. And they might subject another plant to no light, no water, no CO2. So they will now carry out those experiments and see which one actually supports the plants to grow. So at the end of their experiment, they will come out with a result. So probably the result of the experiment supports any of the hypotheses. Maybe the result of the experiment supports the hypothesis that light, CO2, and water makes plants to grow. So they will have it as a conclusion. So at this point, they've done the analysis of the experiments. So after the analysis, if after analysis the hypothesis doesn't come out true, they can remodify the hypothesis, like try to change the idea and go back to experiments. Okay, so now after this analysis, then if the hypothesis is not true, then it becomes a theory. They bring forth a theory from the experiment that has been done. So now after the experiment, after the theory rather, other scientists will also work on that same experiment, carry out that same experiment. They will follow that same method and see if they will arrive at the same results. Now, if they arrive at the same result, then a law can then result. So they can derive a law that, okay, for you to be able to achieve this, so things must be done. So that's how scientists actually comes about discovery of so many things, and today we are actually enjoying the work of science. So when we are talking about the scientific methods, we are talking about these various stages that scientists follow to carry out research and discovery, and that's why we call it a systematic approach. So let's look at application of chemistry. Chemistry is applied in our everyday life as different activities take place in the environment. The effect of chemistry is felt in different aspects of life, such as cooking, washing with soap or detergents, digestion of food, drugs production. We also have other application of chemistry in petrochemicals, plastics, rubber, paints and coating, cements, fertilizers, soap, detergent, sugar, glass, ceramics, paper, and so on. So you can always think of more applications of chemistry. You know, the application is just like the uses of chemistry. Now let's talk about career prospects in chemistry. When we are talking about career prospects in chemistry, we are trying to talk about things you can do if you study chemistry. What can you do if you study chemistry? So we have pharmaceuticals like drug development. We also have chemical engineering, so you can become a chemical engineer. We also have mining and metallurgy. This has to do with extraction of metals. Then we also have petroleum and petrochemical engineering. Then we have quality control personnel. That is, you can become a quality control personnel in maybe industries, food industries, pharmaceutical industry, if you study chemistry. Then we also have chemical analysis, forensic science. So all these are various career prospects in chemistry. Assignments. Not less than 15 lines discuss the adverse effects of chemistry. Now, when we are talking about adverse effects of chemistry, it's more or less like disadvantage of chemistry. You know, when we have advantages like applications, we can also have maybe the disadvantages. So these disadvantages are like the adverse effects of chemistry. For instance, production of war weapons, you know, they could fall under the adverse effects of chemistry. Nuclear weapons, they could fall under the adverse effects of chemistry. 2. How will you define chemistry? 3. Discuss how scientists make their discovery. Okay, so that will be all for today's class. Please do endeavor to like this video and subscribe to my channel. Thank you. See you some other time. Bye.